What's happening, Hardscapers? Today I'm going to talk to you about biaxial and uniaxial geogrid, where and when you should use them, as well as an experiment that went not exactly as planned, but still gives you a good example of why this helps in stabilizing the aggregates in your base material, as well as in behind retaining walls, where and when you should use it, and why this is such a great insurance material for you to use, extremely inexpensive compared to the rest of the project, going in to provide your client with some peace of mind, as well as to upsell yourself compared to the competition around you, letting them know that you use extra things in your base installations, in your retaining walls, to ensure that that project is going to be around for a long time. Let's get into this. Since my time starting in the industry back in 2007, geogrids have become increasingly popular in this hardscape industry, used in both segmental retaining wall and pavement applications. Not only is it an inexpensive way to add to the longevity of the hardscape projects that you are installing, it is also a great way to help your company stand out from the competition when explaining to your clients the benefits of this product. When we meet with clients, we always have a small piece of fabric in geogrids that we use in our installation on a keychain that allows us to show off what this product is and explain to them the benefits of using this product in their installation. It has helped us build authority when meeting with clients and to ensure them that we are there to build them a project that is going to stand the test of time. There are a couple types of geogrid that are used to stabilize soil material or angular granular material. This prevents the movement of that material caused by dynamic loads and therefore prevents the movement of the structure it is helping to stabilize, whether it is preventing the movement of material behind a retaining wall to reduce the pressure on the wall, or preventing the movement of granular material below pavement to reduce the movement of the pavement surface, and to spread out that load over a wider area. Geogrids work by interlocking the granular material or soil placed on top of them. The holes in the geogrid are referred to as apertures, and it is these holes that allow for the strike through or the pushing through of the material into these holes on top that create lockup and the stability that comes with that. It works similar to that of a snowshoe, as it spreads the load on top of it out over a larger area, helping to disperse that force that is experienced. Along with the aperture size and a well-graded angular granular material, the strike-through and compaction helps to interlock these granules to create optimal performance of the geogrid. The lesser the granules of the aggregate, the less they will lock into the apertures of the geogrid, providing less stability. Think of the fine granules of a sand trying to lock into the larger apertures of geogrid and how difficult that lockup is to achieve. In addition to this, soils and other materials pull apart under tension caused by a load. However, geogrids have the strength to withstand that tension, allowing for that load distribution. Geogrids are used in retaining walls, patios, walkways, driveways, as well as in further applications beyond the residential hardscape industry, including embankments, steepened slopes, bridge abutments, and roads or other structures. Geogrid is used in slope stabilization, soil stabilization, and soil reinforcement. We're going to talk about two different types of geogrid and their applications. Uniaxial geogrid is the geogrid used in retaining walls. This has strength in one direction and is used predominantly in retaining walls. It is produced using a combination of high tenacity polyester or polypropylene yarns that are twisted together with a single yarn and then weaved or knitted, forming flexible junctions, and is coated in an additional protective layer of polyvinyl chloride, PVC, or latex. These geogrids are more flexible than the other two based on what they're made of. This makes them an excellent solution to be placed or squeezed between two layers of retaining wall block, using the weight and locking mechanism of the retaining wall blocks to tie it into the wall and creating one solid mass. Using geogrid in segmental retaining wall applications, along with a proper batter or setback of the retaining wall, can increase the height to which a retaining wall can be installed to. When installing the uniaxial geogrid in a retaining wall, it needs to be rolled out perpendicular to the wall at a length specified in the manufacturer's specifications, which will depend on the height of the wall, subgrade, and soil conditions, and the load that the retaining wall is supporting. It is important that the roll is rolled out in the correct direction to the wall, as uniaxial only has strength in one direction. If it is rolled out parallel to the wall or not following the manufacturer's instructions, it will not provide the stability required in that application, and this may cause the wall to fail. Typically, the geogrid extends through the backfill material of the retaining wall, usually some sort of angular crushed aggregate, and into the structural soil beyond the retaining wall. The apertures reinforce the soil behind the wall, preventing the movement and subsequent force that would be applied to the back of the retaining wall. It is never overlapped in its installation and requires a minimum of 4 inches of aggregate to be placed on top to achieve its performance of stabilization. When installing a curved retaining wall, this means that you cannot overlap that geogrid going around a curve, and therefore you would complete one layer of geogrid where that geogrid will not overlap, continue on to the next course of the retaining wall, assuming it's at least 4 inches in height, and then install the following layer of geogrid that was missed on that previous layer. Biaxial geogrid we use in our patios, walkways, driveways, raised patio applications. It is a geogrid that has strength in both directions and stabilizes aggregate base material of pavement structures. It is made of polypropylene that is stretched in both directions, providing tensile strength, and holes are punched into this, creating the apertures. These holes are square, and this grid is more rigid compared to a uniaxial geogrid. The load on the surface of the pavement causes aggregate and soil to move in every direction. Think of a boot stepping into mud. The mud that was previously underneath the boot moves in every direction outwards and up surrounding that boot as it is forced into the mud. This is what is happening to a lesser extent when a dynamic load moves on top of pavement. That load is distributed through the pavement and downwards into the base material and subgrade. Installing a biaxial geogrid as deep into the surface as possible with a minimum of 6-inch overlap between pieces allows for the interlocking of aggregate to prevent the movement of that base material and subsequent subgrade under the load experienced on the surface of that pavement. In our business, we specifically use biaxial geogrids in raised patio applications where we want to tie in every side of the retaining wall and stabilize the aggregate base underneath the pavers, creating one complete system. We also use it in walkways, patios, and anywhere we can, including driveway applications, to be able to stabilize that material. In our installations, because we use a geotextile to separate our subgrade from our base material, what we'll do is we'll do a 4-inch lift from that geotextile and then install our biaxial geogrid with another 4-inch lift on top of that for our pavement structures. That means our walkways and patios, when not installed on a synthetic base, are being installed with an 8-inch base being stabilized by that biaxial geogrid and separation, filtration, and drainage being provided by that geotextile at the bottom of our base installation. If you have any further questions about geogrids, their applications, please leave a comment in the comment section, like this video if you found it helpful, and subscribe to the channel for more hardscaping content.